We want to start today by reminding ourselves of the ratios in the iconic triangles, the 30-60 right triangle and the 45-45 right triangle. We built these last time, and so we have all these. We want to know our trig ratios, sine, cosine, and tangent for angles with reference angles of 30, 45, and 60. This will help us take our trig functions out of right triangles and put them onto the coordinate plane, which will help us put them onto the XY axis as sinusoidal functions, not just circles. We want to recognize these values. Sine of 30 is a half, cosine of 30 is √3/2, tangent of 30 is √3/3. Sine of 60 is √3/2, cosine of 60 is 1/2, tangent of 60 is √3. Sine of 45 is √2/2, cosine of 45 is √2/2, tangent of 45 is equal to 1. Now that I've said that one time, everybody has all those values memorized, so we're good to go, right? Because that's how it works. You've seen it happen one time, it's memorized. Everybody remembers everything, right? That's totally not how it works. If it seems like a lot to remember, that's only because it's a lot to remember. If it becomes difficult to remember, that's because you don't want to remember it. Trust me, you still remember the words to your favorite song from 5 years ago. I'm approximating when you're 14. Because those are the songs that you're going to remember for fucking ever. You can't get rid of them. You're going to be embarrassed by remembering those songs. That's just the human mind just remembers different things. Right. Now I'm thinking of all the weird shit that I remember. I think I've already mentioned. I remember my girlfriend's phone number when from 12 years when I was 12 years old. I also know does anybody know the TV show Animaniacs? So one of the characters on Animaniacs made a song called Yakko's Wood. And he just lists the countries of the world at the time. And my friend bet that I could not learn it, but he forgot that I had like a 45-minute commute every day. So like a month later, I said, well, hey, Steve, United States, Canada, Mexico, Panama, Haiti, Jamaica, Peru, Republic of Dominica, Cuba, Caribbean, El Salvador, too. There's 4 verses. I knew them all. I don't know if I can do it right now. And yet, hey, did you write that email? Fuck. Anyway, the human mind can remember a huge amount of stuff. It just depends on how motivated you are to remember it. It's okay if you don't remember because you're always going to be armed with a calculator. And so you're always going to be able to get at these approximations. So if you can remember what the approximations are, if you just remember that they're square roots, right? If you just remember that they're square roots, then you can be like, oh, wait a second, what is the sine? It's a sine of 45. The sine of 45 is 0.7071. If I square that, I can't see the buttons, 0.5. So it's the square root of 1/2. So it's √2/2. There's a lot of ways, a lot of structure that you can use to remember these values. Here's what we want to do. We want to take our iconic triangles and combine them with reference angles in all 4 quadrants. So we can know things like sine of 150 is 1/2. Cosine of 150 is -√3/2. And you'll really be able to impress your friends at the party when the subject of trigonometry comes up. Because I know that happens all the time, right? Your friends are like, oh, I don't know, man. What is the exact value of cosine of 150? You'd be like, oh, -√3/2. And your friends will be like, oh, whoa. And you'll be like, oh, I know, right? I can do all 4 quadrants. And then your friend tries to one-up you. They're like, oh, yeah? United States, Canada, Mexico, Canada. So it becomes a whole thing. So with that in mind, I have and exercise. We're just gonna take the 30, 45, and 60 and put it in all four quadrants. It's not gonna fit on one page. I should have made it smaller. Or on one screen. We need a nice, clean way to organize all this information so we can keep track of it. And we're going to look for patterns. And one way that we can organize this is on a unit circle. So we're going to build a unit circle. The unit circle refers to a circle with a radius of 1. So unit refers to a circle of radius 1. And the center is at the origin, 0, 0. So that's what we're talking about with a unit circle. So here is a unit circle. When you draw your unit circle, you're going to want to know what, here's our radius of 1. We're also going to want to be able to find where 1/2 is. We want to find where 1/2 is. Notice that 1/2 is featured prominently in this 30-60 right triangle. Cosine of 60 and the sine of 1/2. Cosine of 60 and sine of 30 are both equal to 1/2. So that's going to be important in our unit circle. We want to know where those 1/2s are, because we want to be able to easily find 30 degrees and 60 degree reference angles inside the unit circle. If you would recall, when we first started breaking out of our right triangles, sentence is difficult today. I don't know if this is a more coffee problem or a less coffee problem, but I know what solution I'm going to be applying. When we first started breaking our trig functions out of right triangles and associating them with coordinates, we found sine of theta was y over r, cosine of theta is x over r, tangent of theta is y over x. This connects to what's positive where. Sine is positive where y is positive, because sine of theta is y over r. Cosine is positive where x is positive, because cosine of theta is x over r. Tangent is positive where x and y have the same sign, because tangent is y over x. So if I got positive over positive, that's positive. If I got negative over negative, that's positive. That's why telling your friends to cheer up when they are unhappy doesn't work. Cheer up is a positive, unhappy is a negative. You're just going to get more negative. See what I mean? It's because it's multiplicative. So if your friend is sad and you want them to be happy, tell them to cheer down, because that's two negatives. That should make it positive, right? I mean, it's just math. Also, that's just not how emotions work. Like if someone is angry, you can't just be like, oh, calm down and have them instantly calm down. That's just like not how it works. But it makes sense, because if you're angry and someone says, calm down, that's a negative times a positive. That's going to make me more angry. And that makes sense, because you're multiplying a negative by a positive. It's going to be more negative. See, it's just math. Maybe this is why I couldn't be a psych major. Anyway. So we're going to use these 1/2. That's why I want to mark off where 1/2 of the radius is. So sine of 30 is equal to 1/2. So if I want to be able to find out where 30 is, I need to find out where y is equal to 1/2. So here's where y is equal to 1/2. And if I just intersect those points with the unit circle, there's y equals 1/2. There are 2 points with y coordinates of 1/2. And that's how we can find points on the unit circle that correspond to 30-degree reference angles. In the first quadrant, that's going to give us a 30-degree angle. In the first quadrant, that'll give us a 30-degree angle. In the second quadrant, that'll give us a 150-degree angle. I don't know if I can get these. So that's how we can locate the 30 and the 150. Sine of 30 is 1/2. Sine of 150, also a half. If we want to locate 60, and we don't just want to guess, notice that cosine corresponds to x. Cosine of 60 is 1/2, and this is a unit circle, so r is equal to 1. We're going to find where x is equal to 1/2. And that's where we will have a 60-degree angle. We'll take our unit circle, find where x is equal to 1/2, intersect that vertical line, unit circle, x equals 1/2 with the unit circle, and there's our 60-degree angle. That's 60 degrees in quadrant 1, and 60 degrees in quadrant 4. So there is our 300-degree angle. Cosine is positive where x is positive. Sine is positive where y is positive. Sine goes with the y coordinate. Cosine goes with the x coordinate. We know that sine is negative in quadrants 3 and quadrants 4. So if we drop down to where y is equal to -1/2, here's how we'll find our 30-degree reference angles in the third and fourth quadrants. Thirty degrees in a quadrant 3 is 210, so that's a 210-degree angle, and 330 in quadrant 4. Sine of 330 is -0.5. Sine of 210, -0.5. I can't leave it like this. I have to draw that x equals -1/2. So x is negative in the second and fourth quadrant. Cosine is negative in the second and fourth quadrant. Cosine goes with the x. So that's how we will locate our 60-degree angles. We look for x is 1/2. And like we talked about earlier, 60 degrees in the second quadrant is a 120-degree angle. 60 degrees in third quadrant is a 240-degree angle. We're also going to want to know about the angles at the quadrants. We're also going to want to know our quadrant angles. So we know that here on the x-axis is where we have 0 degrees. And on the negative x-axis is where we have 180 degrees. In between on the positive y-axis, we've got a 90-degree angle at the positive y-axis and 270 on the negative y-axis. Stopping at our quadrants, and we're counting around by 30-degree angles. 130, 230, 330, 430, 530, 630, 730, 830, 930, 1030, 1130, 1230. We want to associate sine with the y coordinates, cosine with the x coordinates. We want to remember what's positive where. Sine is positive where y is positive, so that's quadrants 1 and 2. Cosine is positive where x is positive, and that's quadrants 1 and 4. Sine is positive up here. Cosine is positive over here. Questions? Remember that cofunctions of complementary angles are equal. So here for 30 degrees, the cosine, the y coordinate is 1/2, and we know that the cosine of 30 is √3/2. So if we drop this down here, that'll tell us where √3/2 is. So the coordinates of that point that correspond to 30 degrees in standard position, the x coordinate will be √3/2 cosine of 30. The y coordinate will be 1/2 sine of 30. So the coordinates here, √3/2, and the y is 1/2. At this 60-degree angle, the coordinates are going to be x is 1/2 and y is √3/2. Notice that the coordinates going around the unit circle, the x coordinate is the cosine, the y coordinate is the sine, because x corresponds to the cosine, y corresponds to the sine. I'm going to take these same two values, 1/2 and √3/2, and remix them in quadrants 2, 3, and 4 with some minuses thrown in there. In the second quadrant, our x is negative, so the coordinates at 120 are -1/2 and positive √3/2. What are the coordinates at 150? Negative √3/2 and positive 1/2. Dropping down into the third quadrant, what's going to happen to both coordinates? They'll be all negative, because in the third quadrant, x is negative, and y is negative. So at 210, our coordinates are negative √3/2, negative 1/2. As the cosine corresponds to the x, that's the bigger one. It's the y that's 1/2 here. And 240 will be negative 1/2, negative √3/2. Similarly, 300 will have a positive x of 1/2 and a negative √3/2. 330 coordinates will be positive √3/2, negative 1/2. X is positive in quadrants 1 and 4. Y is positive in quadrants 1 and 2. Sine is positive in quadrants 1 and 2. Cosine is positive in quadrants 1 and 4. On this circle of radius 1, what will the coordinates be at 0 degrees? What are the coordinates down here? Here's 0, 0. What's the x coordinate? That's up here. 1, and the y coordinate? 0. So we go 1, then 0 up and down. So the coordinates here are 1, 0. The x corresponds to cosine, y corresponds to sine. So what is the cosine of 0 degrees? Cosine of 0 is equal to 1, and sine of 0? 0. At 90 degrees, what are the coordinates of that point? X coordinate, 0, and y coordinate, 1. So what is the cosine of 90 degrees? And the sine of 90? Continuing around the unit circle, when we get to 180, what are our coordinates? -1, 0. So what is the cosine of 180? And the sine of 180 is 0. Wow. There's only one more stop. At 270, what are the coordinates? 0, -1. So what is the cosine of 270? And sine of 270? Then when we get back to the beginning, we get cosine of 0 is the same as cosine of 360. And the sine of 0 is the same as the sine of 360. Here's the unit circle with the 30s and the 60s laid out. If we track the x coordinate going around the circle, starting off at 0 degrees, the cosine starts at 1, then √3/2, which is 0.8660, then 1/2, then 0, then -1/2, negative √3/2, -1, negative √3/2, -1/2, 0, +1/2, positive √3/2, back to 1. So we went 1 down to, oops, your perspective, 1 down to 0, down to -1, back to 0, back to 1. So 1 down to 0, down to -1, up to 0, up to 1. If we watch what sine does, sine starts off at 0 and then goes up to 1. So sine starts off at 0, goes up to 1, down to 0, down to -1, back up to 1. The x coordinate corresponds to cosine. The y coordinate the x coordinate corresponds to cosine. The y coordinate corresponds sine. I'm saying CO too much. It's also late in the day, so wires start to get scrambled. Any questions? It only seems like a lot to remember because it's a lot to remember, and you have to remember all of it all the time in perfect detail. But it is super organized. That's the advantage that we have. It's super organized. How's everybody okay? Things we want to associate. Sine goes with the y, cosine goes with the x. Also notice for the 30s and the 60s, those are associated together. 30, 60, 90, those are the ones that go together. Numbers that are in play are 1/2 and √3/2. Got to figure out how to combine it. Sine of 30 is 1/2. You remember that one? That tells you that cosine of 30 is √3/2. That tells you that the sine of 60 is √3/2. That tells you that the cosine of 60 is 1/2. Plus or minus, you get from the quadrants. Top 2 quadrants where y is positive, that's where sine is positive. Right 2 quadrants where x is positive is where cosine is positive. Is everybody okay? Everybody looks stunned. This is what everybody looks like every time I do this unit circle thing. You all look at me like this. It's like, are you kidding me with this? And I draw it, and it takes me that long to draw it because we draw the circle, and then we draw the halves, and we use the halves to find the 30s and the 60s. Use the halves to find the 30s and the 60s. Any questions? Now that we've drawn the symbol on the page, we can finish the incantation and summon the mind flayer. I'm just kidding. I'm not going to summon mind flayers. All right. This is what we want to remember. I want you to learn these values going around the unit circle. You don't have to memorize these values. You just have to remember what they are. You have to be able to walk in here on Tuesday and I'm like, what is the cosine of 240? You know, like a cosine of 240 is -1/2. All the things that go into that. When you hear cosine 240, you're thinking 60-degree reference angle. You're thinking quadrant 3. So cosine is negative, and the value is going to be 1/2. All those things just happen. You're worried about remembering all that. You remember that 7 times 8 is 56. It's the same kind of thing. How's everybody okay? The disadvantage you have now is that you're not like a small child. They're really good at remembering shit like that. By the time we're kind of like adults, it becomes so much harder to just like cram stuff into our brains. So. And we try to do this like when you're teenagers. When we try to cram stuff into your brain, your natural response is to be like, oh no, fuck you. I'm not learning anything. It's like, well, why we should have got them earlier. It's like cigarette rules. You got to start young. All right, that's gonna do it for today. That's gonna do it for this week. Everybody have a nice, long 4-day weekend. And thanks for playing.